Okay, welcome everybody. Good morning, good afternoon, or good evening, depending on your time zone. Welcome to the webinar on how to run containers at the edge with Mirantis Container Runtime. I will be your host and presenter for today. My name is Kevin Ng. I'm a Senior Solutions Architect here at Mirantis. So a little bit about what we're going to talk about today. First of all, we want to look at what are some of the use cases for containerization at the edge? I mean, why do we want to do that? What are some of the benefits and perhaps requirements of your edge environments? A bit of comparison between different orchestration methods, between Kubernetes, Swarm, or running just containers on the edge with Mirantis Container Runtime, and essentially what it probably looked like in practice. So before we start, I think it'd be a good idea to define what we mean by the edge. And as you can see here, there are a couple different levels, starting with your core data centers at the top, and which generally consist of fewer locations, but containing several nodes and workloads. So these are your traditional centralized facilities for storing and processing data. And their primary role is to host applications and data on a large scale, serving users worldwide. And some of the use cases served by your core data centers will probably include things such as your large-scale data processing, because your core data centers are often used to process vast amounts of data that require significant computational power. And this might include things such as your machine learning algorithms or complex financial modeling. And given their robust and fault-tolerant infrastructure and ample resources, another use case really revolves around backups and disaster recovery. And again, because of the resource availability, and really, if you think about it, almost near infinite ability to scale up, core data centers serve as a very efficient backup repository and disaster recovery sites. So these core data centers then often feed into, or depending on the direction of traffic, are fed by the regional data centers, and these are on the second level over here. The regional data centers tend to be more numerous and more widely distributed than the core data centers. They're designed to serve specific geographic areas, reducing the latency compared to your core data centers. And at the same time, they're also smaller and consist of smaller but still significant number of nodes and workloads. So with regional data centers, you would probably use them for things such as your localized content delivery, serving content closer to your end users could help reduce latency, improving the user experience. And also things such as compliance and data sovereignty, because in some cases, regional data centers are used to ensure compliance with things like data sovereignty law. So that's, for example, GDPR, where servers need to lie within the the EU. I better correct that. Or with same with Canadian data privacy laws as well, where the servers need to lie within the boundaries of the Canadian continent, or the Canadian nationality. So from there, we then move down into the edge compute locations. So our locations over here. Now these locations are still clouds, and this consists of a few dozen nodes and hosting a few dozen workloads. And that exists in potentially hundreds of thousands of locations, such as your cell towers, your branch offices, and so on. So the edge computing pushes data processing and services as close as possible to the end users, which further reduces latency and bandwidth usage. So some of your use cases here would be for things like telecommunications. In the telecom sector, your edge computing allows for real-time analytics of network performance. And this enables your providers to provide improved network traffic management and deliver high-quality services. And if we take this to a larger scale, like for example, smart cities, edge computing also help analyze real-time traffic data to optimize traffic light timings, for example, and therefore reducing traffic congestion. Or things such as monitor utility usage for more efficient resource management. So you see over here, this is still relatively significant, right? You're talking about dozens of servers in locations here. But then these clouds then serve the far edge layer. So when we start pushing the boundary here and go further into the edge, these far edge layers are also known as your customer premise equipment. So these are things such as your single servers or routers that can exist in hundreds and thousands or even millions of locations and serve a relatively small number of workloads. We see these in places like individual stores or individual labs. So as you can see, then it'll probably be good for use cases such as healthcare, where edge computing can help enable more efficient processing of, let's say, lab results. We're reducing the number of transferring potentially terabytes of data from lab equipment to a data center. And this is an actual example from a conversation I had with a potential customer of mine, where they have, in some cases, more remote lab locations where it's not really practical to send out server-grade compute equipment to those labs, because sometimes the footprint is so small that you need consumer-grade equipment that are being placed out there. So, but at the same time, because of the lab analytics and doing things such as genome processing or even looking at blood samples and so on and so forth, there's a lot of data to be processed. So transferring between a remote site back to a data center is not all that efficient. It'd be more efficient to process the data at the location and then just send back a summary to your data centers. Now, second, and probably a pretty prominent use case as well, is in the retail industry. So in that industry, the edge computing can be used for real-time analytics to monitor inventory, customer behavior, even security, right? Your monitors within the stores, and therefore improving your overall store operations. And again, within a retail location, sometimes the footprint could be quite small. So you may have perhaps one or two consumer-grade equipment to act as your servers, and also at the same time compute nodes. And if you take that into a little bit further, your industrial IoT manufacturing and perhaps logistics. Edge computing enables your real-time analytics for predictive maintenance of equipment. It helps to prevent machine failure by analyzing data on the spot and predicting possible issues. And when we talk about things like logistics, it'll be easier for you to, let's say, schedule resources in terms of transportation, in terms of manufacturing, and so on, if the processing can be done in real time with less latency going back and forth between the data centers. And then if we take a further step into what's called the deep edge layer, whoops, sorry about that, or the consumer layer, these are going to be your IoT level devices or your mobile devices. So these are things such as your smart home devices, thermostats, security systems, and with the power on the edge, they can use that to process data locally to make rapid adjustment based on their environment. Because if you have a thermostat, let's say, for example, that has to send data back into the data center all the time, that's going to take a lot of time and a lot of bandwidth costs, really, just for simple things such as adjusting the temperature, right? There's also wearable tech. My favorite tech right now is my Apple Watch that is essentially on my hand all the time, and essentially tracks all my fitness, my health information, and again, processing that data locally, allowing for real-time feedback on what I'm doing for today, the number of steps, what's my heart rate, and so on and so forth. That is very good to provide me instant feedback, and I don't have to, again, my watch is not connected all the time to a data center. So, and that also translates into healthcare, right? So your remote monitoring devices can process patient data in real time, enabling faster response time to critical health events. Because in healthcare environment, you probably need a lot of the things in real time because it is literally life and death scenarios. Now, of course, with the power now available on mobile devices, or even for devices like my Apple Watch, the line between your consumer deep edge and far edge is sometimes blurred. But this essentially provides a broad stroke framework for defining the different levels of the edge. So now that we have a definition of what the edge levels are like, why do we want to do that in the first place? What's the point of running your containers at edge environments? So you see, there are probably going to be several benefits from the use cases that I mentioned earlier, but I'll go through that in more detail in the following slides. First of which really is improved performance. Now, having containers at the edge really brings the computation and data storage closer to the source, reducing the need for data to travel long distances to a centralized data center. Of course, a couple years back, the data that we generate within the edge devices are actually perhaps at a scale that is still manageable, But now with more and more data being collected and more real-time data and more and more data points that are being collected at the edge devices, latency increases exponentially with the amount of data that needs to be transferred back and forth between the devices and your data centers. So because you're doing all that processing and storage at the source location, this greatly minimizes the latency and results in significantly faster response times, which is crucial in use cases such as autonomous vehicles or real-time analytics where every millisecond counts. And secondly, it also provides better data control. Edge computing allows for the processing and analysis of data at the point of origin, like we mentioned in the previous slide, which means the data can also at the same time be filtered and processed locally with only the relevant information sent back to the central servers, which again further reduces the volume of data that needs to be transmitted. So like the lab result scenario that I've mentioned earlier, you're processing blood works and you're sequencing genomes. Again, that's a lot of data for to be sent to the pipelines back and forth. So instead, once it's summarized, then you only have a result, which is perhaps a single line or a single file that can send that it needs to be transmitted. So that, first of all, saves on bandwidth issues, right, and reducing costs and time needed. But at the same time, it allows for data control and helps comply with data privacy regulations. So things such as HIPAA in the United States dictates, well, perhaps doesn't dictate, but provides guidelines on what sort of information needs to be protected. And so you may not want to send that protected information back and forth on the wire as much as possible, right? So you want to restrict your data transmission across geographical boundaries as well. So if there's any data sovereignty rules, perhaps this data can't leave the boundaries of the country, right? So instead, I'm only sending back information that is not protected, that is not PII, and just results such as yes or no, which is not protected information. Using containers at the edge environment can also facilitate scalability. You have horizontal scaling, allowing for the easy addition or removal of container instances based on the demands, but also at the same time supports vertical scaling, which involves adding more resources to existing containers. So this flexibility of scaling helps accommodate fluctuating workloads without requiring significant changes to the infrastructure, thus enhancing your efficiency and reducing costs. And one of the points that I touched on earlier as well, right? Because with the better control of data, with the reduced amount of information that is being transmitted, running containers at the edge could also improve your security. Not with just the amount of data or the types of data being transferred, but also reducing the attack surface. But because your data is processed locally and only pertinent information is transmitted, it minimizes the risk of data being intercepted during transmission. Now, at the same time, containers by their nature provides an additional layer of abstraction, right, which isolates your applications and their dependencies from each other. At the same time, because your servers are physically isolated as well at the edge location, you have better control over who has access to your workload. Okay, so that reduces the potential of one compromised application affecting the others because you have good isolation between the different environments. So now, last but not least, another benefit of running containerized workloads at the edge location as opposed to things such as virtualized is really your customization and flexibility. The musicians amongst us will recognize this as your guitar pedal board, where it's pretty modular, right? I can add and remove different modules into my pedal board just by plugging and unplugging different wires. And it's kind of the same scenario with containers, because containers offer an environment that is separated from the host systems and other containers, which means they can run different software, libraries, or even system processes without conflict. So this provides the flexibility to run various applications with different requirements on the same machine, our pedal board here. And moreover, because containers can be easily created, deleted, or modified, that provides the ability to quickly adapt to changing business or technical requirements. So that makes containerized applications ideal for edge environments because you need this edge environment to be pretty flexible and low maintenance, right? So you don't want someone or your IT department or your developers to go into every single edge location and set up all the libraries, set up your OSs, make sure all the dependencies are there before you could deploy a business application. That's pretty inefficient, especially when you have a relatively large number of edge locations. So having this flexibility and being able to just essentially plug and play is going to be very beneficial for your edge locations. Having said all the benefits, right? Having provided all the benefits of running containerized workloads on the edge, what are some of the requirements of your edge architecture? So we broadly categorize the requirements or essential capabilities of edge locations into 7 different areas, starting with security and your isolation. So you want to make sure you have effective isolation of workloads, and that's critical to ensure not only that the workloads would not interfere with each other's resources, but also that they can't access each other's data in a multi-tenant environment. You want to make sure you have clear access control and role-based access control policies, or RBAC policies, and systems are required to support appropriate separation of duties to prevent unauthorized access by both good and bad actors. And you want to make sure you have cryptographic identification and authentication of your edge compute resources, right, to make sure that is fully secure, right? What the workloads that you're running on your edge locations are actually authorized to execute and is actually authentic. They are actually what you believe them to be, and not some name squatted container that is being downloaded. Next, you want to have telemetry data, right? So the system must provide the availability to manage the physical and virtual resources required to provide the resources to consumers in a consistent way with minimal input from administrators. So the operations folks must be able to manage all your resources remotely without the need for local hands. Because again, potentially there could be thousands or several tens of thousands of local machines or local locations, and it's going to be pretty inefficient for 1 or 2 people or even in a team to be able to reach all those places physically. And that brings us to the operations side. So your operations needs to be low impact and zero application downtime infrastructure operations are critical. And ideally, you have low or zero touch infrastructure operations that provides an environment where you don't have to have a high maintenance, someone always watching at the same time. So it must have a very high degree of automation and self-healing capabilities, which then perhaps leads to the fact that the system must consist of self-contained operations with minimal dependencies on remote systems that could be impacted by low network bandwidth, latency, or even an outage. Next capability, we're talking about open standards. So a key feature of edge systems is the ability to rapidly deploy new and diverse workloads and integrate them with a number of different environments. Because your edge machines could be varied between server-grade equipment to consumer-grade equipment that you just buy off the shelf. So, based on the solution, an open standard allows for this flexibility and supports standardization between the different hardware equipment. So you also want things such as a common standard for abstraction of APIs to simplify your development and deployment, and also a standardized virtualization or container engines, right? So this way you're maintaining one standard across all your edge environments. You're not customizing things. You're not having, bespoke processes for 1 or 2 locations or half and half, right? Again, that kind of increases the cognitive load of whoever's doing your operations or development if you have multiple different environments that you have to cater for, right? So customization is good if you're doing it across the board. If you have multiple customized environments, we've seen this before, the maintenance becomes such a nightmare. You have to think about, okay, which one am I working on right now? There's just so much error, room for error in this case. Now you also want to have stability and predictability in your edge locations. You want to essentially leave it there and almost forget about it until you need to work on it moving forward, right? So the stability of your edge location is, of course, critical as well, because it is out there. It is going to be sometimes hard for you to reach at times. So you need to make sure it has things such as graceful recovery from errors, and as well be able to handle things such as harsh environment conditions, potentially unpredictable utilities, and other external services. Now, of course, you will have to make sure you have good performance. within the edge locations, because otherwise there's not much point putting your workloads there. So you got to make sure that to be clear whether the environment provides access to your specialized hardware components, or if it's good enough with just a consumer grade environment. So you have to make sure that on top of your workload, whatever is managing that workload is lightweight enough to not get in the way of you providing your compute resources for your workloads. Okay. Ease of resource management, I'll kind of skip over that because I think we talked about that quite a lot. And an abstraction, which kind of goes back to your open standards as well. So you want to be able to provide a good level of abstraction for your infrastructure components, because your infrastructure can be quite varied between the different environments, right? And it's really, you want to be able to deploy your workloads on just about any infrastructure that is available out there. So what would that kind of look like in practice? Well, I set up a really simple quote unquote edge environment in my home lab, essentially. So let's have a look at what that setup looks like currently. Okay. So this is a very simple 3 quote unquote cluster or 3 environment setup. So we'll have the computer that you're seeing right now, which is our local host. And I'm a developer, or I'm an operations person, and I want to be able to deploy things onto my edge location. And as a developer or as an operations, I want to be able to manage it as well, or view what it looks like at the edge location. So you have our machine over here, and then I've got an edge machine. This essentially is a containerized environment that I've set up in one of my old Mac Minis. Okay, and we'll go through what the resource specs are for that Mac Mini in a second as well. So my workload is really going to run on this environment. We're going to call it the edge, right? And then I've got another computer within my environment, which will act as the regional data center. And this is going to be a management plane that essentially manages the edge locations, right? So what does that look like over here? Well, let's go ahead and swap over to that screen here, okay? So what you're seeing is my quote unquote edge setup, right? So if you remember from the previous diagram, I've got my edge location set up at 10.0.0.77. So this essentially is a very simple Mac Mini. This is actually from years ago. I just have it sitting around. And you see the specs are actually relatively modest, right? You got a 2.3 gig CPU. I think it's got 4 cores in there, and 2 gigs of system memory. Okay, I've got Mirantis Container Runtime up and running on this, and right now I'm just going to deploy workloads using Compose, right? So at the top here, you'll see the number of different containers that are currently running, and let's go ahead and deploy my workload. Okay, let's go ahead and simply use Compose to deploy the workloads. So all that is being defined within the Compose YAML file, and this can be integrated into things such as Swarm as well for better orchestration. And we'll talk about that in a second, right? So I've got my network inventory system running. So think of this as a retail location. I've got an inventory system that I want to maintain within the different edge locations because I want that data local for processing as well. Okay, so over here, this is my interface, and right now it's not up, right? I've got that just deployed. Let's have a look at my environment here to see if my server and database is running. Okay, so over here, my worker and server is up for a couple seconds. So we'll give it a few minutes to boot up. Okay, and let's have a look at an inventory management system, right? So it'll take a little bit of time to run here before it's up and running. Okay, so the benefits, you see, it's actually pretty straightforward. I got everything stored within my local environment. Now, right now, because this is a dev environment, I got all the code here as well. But when you have a production environment, you can simply just have your containers in a centralized location and then push it out to your edge locations for deployment easily. So let's see here, got up and running. So again, pretty straightforward. Now this, by the way, this browser is coming from my developer machine, quote unquote developer machine. So this is nowhere, is only connected through HTTP to my additional server, right? And as you can see over here, I've got all the parts running. And this, again, has a couple different benefits, right? It allows me to have all of my inventory information locally, so that you have better management of your inventory system, and also for analysis at the edge location. Okay. Now, at the same time, let's say, for example, I want to be able to manage multiple environments. So what do we do there? So let me go into my different server. So this is my regional data center server at 10.0.0.8, where I have my Mirantis Kubernetes engine running. So you notice at the edge location, I'm using simple Docker commands on the Mirantis Container Runtime. But at the same time, I could actually attach this to my management plane via both Kubernetes and or Swarm. So let's have a look at the nodes here in my Kubernetes engine. Right, so you see my 10.0.0.77 machine is currently attached to this in Swarm mode. So I'm actually managing this using Swarm orchestration. And we'll talk about that in a second as well, about the different orchestration choices that you have to manage your different edge locations, right? And now I've got my manager here in mixed mode. Again, we'll talk about that in a second. Now, at the same time, if you look at this, I could look at metrics of my worker nodes as well in terms of CPU and so on. You notice it kind of stopped at this point because I just turned on my demo environment about a second ago as well. So a lot of metrics will be there because it's downtime, right? And so that's essentially a basic, very basic setup of what Mirantis Container Runtime will look like if you deploy them on the edge, right? So you have a pretty self-contained environment that you could just work directly into, but you can also attach it to a wider cluster so you can manage it centrally and look at what's going on there in terms of metrics, and also things such as your availability of resources and so on and so forth. So we did look at a couple different things over here, right? So I've got my edge location, which is my Mirantis Container Runtime, which is just the container runtime. I've got the regional data center, quote unquote, that is managing it and has capabilities of orchestrating containers through Swarm or Kubernetes. So with that, what are some of the different pros and cons, so to speak, right? Or strengths and limitations of running just a container runtime at the edge, orchestrating it through Swarm, or orchestrating it through Kubernetes, because there's, again, quite a few different options out there, right? So let's have a look at this. I've kind of provided a very high-level overview and just kind of listed out the more pertinent. If we look at things such as your scalability, feature set, and portability, you notice that Kubernetes rates relatively high, or pretty high, on the scalability and feature set side of things, because it is built to manage large-scale deployments and dynamically scaling applications, so it makes it suitable for high-demand workloads. Swarm mode is good for starting off. It's got a pretty low learning curve, and it is relatively easy to start off, and it is built into the Mirantis Container Runtime. So you have everything out of the box to be able to connect things into Swarm mode. So you have a medium-sized scalability. It does have a good feature set, but at the same time, your complexity and resource usage does come down a little bit when you compare that to Kubernetes. Now, when you look at the individual edge locations, your Mirantis Container Runtime, the scalability and the feature set is relatively lower compared to the other two because it is simply just a runtime, although it does have all of the enterprise-grade functionality in terms of things like plugins, security, all that built in. At the same time, it is pretty easy to get started. Just deploy it onto your edge location and then start building away. And at the same time, the resource usage is much lower because you do have just essentially a container runtime at the edge locations. So in terms of how Mirantis Container Runtime will be able to help you in your edge locations. Now, remember when we're talking about the edge, there are several capabilities that we want to look at, right? So in terms of security, open standards, stability and predictability, and things such as abstraction, Mirantis Container Runtime has enterprise-grade encryption, FIPS 140-2 validated encryption, as a matter of fact, which essentially proves that the components within Mirantis Container Runtime are built using a government-level validated encryption algorithm. So we also have rootless access, seccomp, and all that built into Container Runtime. So you know that whatever you're running on that runtime is going to be secure, and you just have to make sure that your workloads and the way that you're communicating between your environments are also secure at the same time. Now, this is built on open standards. If you go upstream, all the change that we make to Mirantis Container Runtime are fed back into the open source Moby project, which we actually have a number of maintainers within that project as well. We do provide extensive testing on different scenarios and different operating systems to provide stability and predictability. Okay, and because there's a standard API, your Docker APIs and CLIs available, it does provide a standard execution method to the container runtime, no matter what your operating system or your infrastructure is on. So we looked at the individual side of things. And then when you start trying to orchestrate the different container runtimes or different container environments, we then look at the choice between Swarm and Kubernetes. And you think, okay, which one do we want to use? Which one do we want to maintain within an environment? And our answer to that is, why not both? Because as you can see within the Mirantis Kubernetes engine, we actually have all of the different orchestration methods built into the Kubernetes engine as well, right? And for those of you that work with Kubernetes, you notice that Kubernetes obviously never comes alone. You have your Kubernetes, but at the same time, you need to make sure you provide a runtime for that. You have your Ingress controller, you've got your networking, your security, your storage, all that are things that you need to build from the ground up if you're building your own Kubernetes distro. So Mirantis Kubernetes engine has all of these out of the box. And it supports both Swarm and Kubernetes modes with the Mirantis Container Runtime already included. So you have the flexibility to utilize whatever orchestration you like, whether it's the more powerful Kubernetes or the more user-friendly and easier to set up Docker Swarm. And also at the same time, you could execute this within Linux environments or Windows environments. So you have your multiple environments that you could work with at the same time. So in summary, why the edge? Well, in most cases, you probably already have the answer, but at the same time, things that you're going to get from running things at the edge is going to be reducing your latency by providing your processing power where it matters. You could control the data by reducing the amount of data that needs to be sent over the wire. And at the same time, then thereby increasing your security and reducing the attack surface with better isolation. Mirantis Container Runtime can help support you in that edge journey with FIPS 140-2 validation, which is essentially mandated by the US government for all government required resources. So if it's good enough for the US government, it's usually good enough for all security conscious organizations. Providing also additional security features such as image signing to make sure that whatever image you're executing on the runtimes is actually validated and authentic. We have Swarm clusters orchestration between your different container environments, and it's a supported CRI into Kubernetes. So if you want to use Kubernetes as well, it is also already supported and supported on many operating systems. Now, this can be then orchestrated and maintained using the Mirantis Kubernetes engine with built-in cluster management dashboard. It manages the lifecycle of a container cluster, deploying both Swarm and Kubernetes workloads, and it runs on both Windows and Linux containers. Okay. At the same time, it also has built-in role-based access control. So you have that authentication and security built into the orchestration out of the box. So you have your LDAP process, SAML process need as well to connect to your authentication mechanisms. So to learn more, please visit www.mirantis.com. There are white papers, case studies, and if you'd like to as well, please reach out to us to find out more information about what we talked about today. Yeah, so I think that's pretty much that. So if there's no further questions, I'm going to appreciate you all being here, and I very much enjoyed the fact that I'm able to share this information with you. Once again, if you have any additional questions or you'd like to find out more, please visit mirantis.com, or my contact information was in an earlier slide. Feel free to reach out to me directly as well. and hope you all have a great rest of the day or the beginning of the next day, depending on your time zone, and look forward to seeing you in a future webinar.